Good morning to all. In the previous session, we started operations on signals with respect to amplitude parameter. There we discussed the four operations. One is amplitude scaling, second one is addition, subtraction and multiplication of amplitudes. Now first case already over. In this session, we are going to start the remaining three cases. Let us start. Let us start. So the three remaining cases on amplitude parameters, operations on signals. The second one is called what? Amplitude addition. Addition of amplitudes. Second one, next one, subtraction of amplitudes. Next one, multiplication of amplitudes. These three are very interesting. All three can be discussed in the single session, single topic. That much essence and essentials it is having. Now let us start. Whether multiplication or subtraction or addition topics are concerned, minimum how many number of variables do we need? Minimum 2 variables we need. Otherwise we can't make any of these arithmetic operations. Similarly, for these three operations, we need minimum 2 signals. So if any question is given on these three topics, the question should contain 2 signals. They should give. Then only we can make addition or subtraction or multiplication. Now let us start. The question will be like this. This is t. This is the first signal, x1 of t. It will be, for example, -8 to, for example, 8. The amplitude equal to 3. Amplitude equal to 3. Now let us consider another signal. It is equal to t. The second signal we make it as x2 of t. It is, for example, -3 to 3 with amplitude 2. Look at. These 2 signals are given. Here amplitude is 3 in the first sketch, the first signal. Amplitude is 2 in the second signal. These 2 signals are given. On these 2 signals, now we are making addition, subtraction, multiplication operation. Very interesting, just look at. This is a small signal. This is the big signal. Look at. The small signal just we have to keep in the big signal, first one. Just look at. Combining these 2. The first operation what we are going to discuss, that is called what? Addition. Addition operation. First, make a combined graph. Look at this one. This is t. It is a combined graph. So first what you have to make it? Make first the big signal. This is -8 to 8. So amplitude is what? 3. Now just look at, we are drawing the first signal as it is. Now the small one, keep the small signal in the big signal. So let it be -3. This is -3. Its amplitude how much? 2. So just you can make it 2. We combine these 2. Now just look at. One thing students have to remember. The width of the small signal, width of small signal, that is -3 to 3. Width of big signal, that is -8 to 8. Look at. Between -8 to -3, look at. Between -8 to -3, in this space, there is nothing. Full white space is appearing. Full white space. There is no signal. There is no signal means what? From -3 to -8, there is no signal. No signal means what? 0. Come this side. From 3 to 8, full white space is appearing. There is no signal, empty space. So from -3 to -8, no space. So here the amplitude is 0. Here what is value? 2. Amplitude is 0. Here amplitude is 0. Now the small signal is having 2 amplitude. 2 amplitude means what? From this to this, amplitude is 2. From this to this, amplitude is equal to 2. For the big signal, from this point to this point, the amplitude level equal to 3. Similarly, this point to this point, the amplitude level equal to 3. All are 3 to look at. I think students understood very clearly. Again, just look at, in the first instance, we made a big signal. We put the small signal inside the big signal. Just we make representations of various amplitudes for our understanding purpose. Here it is 2 means what? Throughout this one, 2, 2. 3 means what? Throughout the level it is 3, 3, 3. Here no amplitude, so 0, empty space. Here empty space. Now just look at, addition means what? Now just look at the signal. This is T. This is a combined signal because we are adding these two, x1 of t, x2 of t, adding. Now just look at same, -8, -3, 3, this is 8. Amplitudes. Now, look at -8 to -3. Between this space, the operation is addition. Addition means what? Addition of amplitudes. Therefore, 3 plus 0, how much? 3 plus 0 equal to 3. In which period? From -8 to -3, adding these 3 signals. So, from -8 to -3, how much? This is, for example, this is 3. This is 3. Now, up to this level, the amplitude is equal to 3. That means from -8 to -3. This is -3 to -8. The amplitude equal to 3. Between -3 to 3, the amplitude 2 plus 3, how much? 5. Here it is 5. And between -3 to plus 3, the amplitude is equal to 5. Up to this one, amplitude is equal to 5. Between 3 to 8, the amplitude is 3 plus 0, 3. And between now, here the amplitude is equal to 3. Now just look at, here add this one. Amplitude scale, addition of amplitudes. Again, just look at, we have to divide between 3 parts. You have to divide. In the first part, between -8 to -3. Second part, -3 to 3. Third part, 3 to 8. In this way, we have to divide these 3 parts. Now, in this way, look at, between -8 to -3, no amplitude, 0. Up to this level, 0 plus 3, how much? 3. Up to this level, the height amplitude is equal to 3. But from -3 to 3, the amplitude of small signal equal to 2, amplitude of big signal equal to 3. 2 plus 3 equal to 5. Here amplitude raising, addition of these two amplitudes, it is raising 5. So here the amplitude is equal to 5. Now, from 3 to 8, the amplitude is equal to 3 plus 0 equal to 3 level. Now, just look at, that is the addition operation. Addition operation. Now, same, you have to go for multiplication. Multiplication operation. How to go for multiplication operation. Multiplication means, look at the same graph we are making it. This is t. This is multiplication means x1 of t and x2 of t. Operations and discussion regarding addition and multiplication are same figure. Now put the width. Here it is -8, here it is -3, here it is 3, here it is 8. Amplitudes, it is 2 and this is 3 levels. Now, in the previous case, what we did, we added amplitudes. Here we have to multiply the amplitudes. For these two cases, for addition and multiplication, for these two cases, same figure we have to discuss. Here just look at same width, range we used. Now, in the previous case, in this case, what we did? 0 plus 3, because addition 3. But here the case is what? Multiplication. 0 into 3, how much? 0. From minus 8 to minus 3, how much? 0 into 3 equal to 0. 0 means what? You have to make a thick line, 0. Up to this one, it is 0. Now, from minus 3 to 3, how much? 2 times 3. 2 times, in the previous case, what we did? 2 plus 3 equal to 5. But this operation is multiplication. So, 2 into 3 equal to 6. So, now we have to make it, for example, this is 2, this is 3, this is 6. Now, from minus 3 to 3, 2 times 3, how much? 6. Suddenly raises. So, from minus 3 to 3, here it is 6. Up to which one? Up to 3. Up to 3, 6. Now, again 3 to 8, how much? 0 into 3, how much? 0. From 3 to 8, it is 0. So, draw a thick line. Now, add. Now, look at, that is the multiplication operation of two signals. Two signals, very important concept. Again, just I am telling, look at 3 arithmetic operations we can make on signals. For addition, subtraction, multiplication, we need 2 signals. So, they gave us 2 signals, x1 of t and x2 of t. Are you? x1 of t, x2 of t. So, for that purpose, first we took a big signal and we kept a small signal inside the big signal. Now, just you have to make the demarcate the limits of the small signal and big signal like that. The dotted lines appears space, empty space, no amplitude, empty space, no amplitude. So, put 0, it is 0. Here the amplitude for small signal, amplitude is 2. So, keep 2, 2, same parallel 2, 2. Here the amplitude is equal to 3. Throughout this one, amplitude is equal to 3. Now, in how many divisions we can make? Minus 8 to minus 3, minus 8 to 3, and 3 to 8. 3 divisions we can make. So, here we made 3 divisions. In these 3 divisions, for addition operation, what we made? 0 plus 3 equal to 3. Now, 2 plus 3, for this range, 2 plus 3 is equal to 5. For this one, 0 plus 3 equal to 3. So, according to that, we got this graph. But regarding multiplication, what happens? Here we made 0 plus 3, but 0 into 3 equal to 0. Here 2 into 3, 6. Here 0 into 3, 0. According to that, we made. So, in the new graph, in the new sketch, minus 8 to minus 3, the amplitude is how much? Amplitude is equal to 0. From minus 3 to 3, the amplitude is equal to how much? That is equal to 6. From 3 to 8, the amplitude equal to how much? That is equal to 0. That is the way you have to mention everything like this. Now, in the addition operation, the same thing you mention. From minus 8 to minus 3, the amplitude is how much? Amplitude is equal to 0 plus 3, 3. Amplitude is equal to 3. From minus 3 to 3, the amplitude is how much? This is equal to 5. And from 3 to 8, the amplitude is equal to 3. Now, look at, in this way, you have to make it everything like this. So, this is the addition operation and addition operation and multiplication operation with respect to amplitude parameters. So, out of these 3, addition is over, multiplication is over, now subtraction is remained. Now, regarding the addition and multiplication operations, same diagram is applicable. On this diagram, we have to make either addition operation or multiplication operation on the levels of the amplitudes. That's why all these are amplitude oriented operations. There will be no change in the width. Wherever there is 0, you have to make it a thick line. thick line indicates 0, thick line indicates 0. The remaining one is called what? The amplitude is the multiplication, the resultant of multiplication of signals with respect to amplitude. This is the resultant of operation of amplitude with respect to addition operation. So this is addition, that is multiplication. So this ends this topic. This ends the topic. In the next session, just we are going to complete the last operation, that is subtraction, which is a different one. Thank you.